All right, I'm making a video like this because I didn't make it before I left work. So I'm only going to do one example of translation because it's usually extremely obvious and people get the hang of it. It's not always going to be right and it's not always going to be down. Sometimes it'll be up and sometimes it'll be left. It just depends. So translation is when you move an object from one place to another without turning it or shifting it in any way. So it's just moving to a new place. So it says move this entire shape 3 to the right and 2 down. So instead of trying to move the entire shape all at once, you move each dot. So you move each dot 3 to the right, 1, 2, 3, and 2 down, 1, 2, and there's your new location. I'm going to call that A prime. So then we know that this is where it started and this is where it ended. So we'll do the same thing to the B. We're going to go 3 to the right, 1, 2, 3, and 2 down, 1, 2, and it ends up right there. And we'll put B prime. And then I'm going to do the same thing to C, which is 1, 2, 3, 1, 2, and that'll be C prime. And seeing as though I've shifted every single dot exactly the same amount, that means the entire shape, after I connect it here, has also shifted exactly the same amount, 3 right, 2 down. And that's what translation is. So I'm going to say translate, which means shift to a new location, and then it'll tell you how much they want you to shift every single dot. Okay? Every single shape you're going to see during this video is going to be triangle. Yes, you only have to know how to move one dot, and then you just repeat the process, but it's good to see a practice of an actual shape moved, and it's usually triangles, but not always. Next one here. For this one, we are going to reflect off of the x-axis, creating a mirror image off of the x-axis. So we find the x-axis. For this one, this is the x-axis right here, this line right here. So I'm going to try to make it a little bolder here. So that is now our mirror. Now, the way mirrors work, whatever's on one side of the mirror has to be in the other side of the mirror, okay? So if I'm looking in the mirror and I'm holding a cup and I don't see the cup inside the mirror, something's wrong with the mirror, right? Or I'm holding a ghost cup of some sort. But just in case, that's how this is going to work. So this line now has to have everything on both sides. Now the B is on the actual mirror, so it's not going to move at all. So it's going to stay right there. So I don't have to do anything for the B. So if the mirror crosses the shape, you're like, sweet. Now A, how far is A from the mirror? 1, 2, 3. Which means on the other side of the mirror, 1, 2, 3, A should be exactly the same distance. Okay, if I'm standing 3 feet from the mirror, in mirror world, I should also be standing 3 feet from the mirror. If I'm all the way across the room, leaving the room while I'm standing here, that's not good. So now let's do C. C is on this side of the mirror, which means it also has to end up on this side of the mirror. So now there's C prime, meaning this is where it ended up. And now if I connect A, B, and C here, it's hard doing this while holding the phone. That's pretty good. And that is a reflection off of the x-axis. Okay? Now we're going to do another one down here, another reflection. Now here, it's not one of the axes. So, and this kind of throws people off because it says y equals -1. So you have to find y equals -1. So y equals -1 is right here. So we have to create a line through this dot that does not intersect with x because there's no x in this shape here. So it actually goes across like this. So that right there is y equals -1. There's -1. It goes through here and it doesn't go through there. If it was even slightly angled, then it would have gone through x, and that would have been a different equation. So y equals -1 means it's a line that goes through y equals -1. So now we have our mirror, and we follow the same rules. 1, 1, that's C prime. Then that is 4. So now 4 from the mirror. So I'm going to count 4 from the mirror. 1, 2, 3, 4, all the way down here. Okay, a lot of people accidentally start counting from the x-axis again. You're counting from the mirror, so make sure you know that that's the mirror. Do something like a squiggle. I'm coloring in red. Something that will clarify that that's your mirror. So 2 and 2, and that'll be B prime. That's C prime, and this one down here is A prime. And now I will draw this. Okay, remember that none of these movements we're doing during the video should change the shape of the side, the size of the shape in any way. So if I were to fold this paper where this red line is, this would overlap that. And I'm correct because I followed the rules. Now we're going to go do one more reflection, and that is reflecting off of x equals 2. So we're going to find x equals 2, which is actually right here. And we're going to draw a line through x equals 2. A lot of people would accidentally go like this again. That's called the x-axis. So it's definitely not x equals 2. This right here is a line that goes through x equals 2, but is not going through y. So there's our mirror. So again, we have another dot that's on the mirror, so we don't have to do anything with A. We just have to do B, which is 2 away from the mirror. So I make a dot that's 2 away from the mirror on the same line. You see that? Then I make a dot here, because that's 1 away from the mirror. That's A prime. This is B prime. And now we just connect the dots. A, well, B, C, A. There we go. And that is, sorry about the moving, that is a mirror image of the shape of here. If I were to fold it right here, all of these dots would overlap. You said we're dealing with the dots and not the shape? Okay, because once you move the dots, the shape will go with it. All right, now we're doing rotation. Last ones, guys. We are going to be doing a rotation of 90 degrees. You see how it doesn't say direction? If it has no direction, it'll go counterclockwise, okay? Because that's the direction in which the quadrants are in. So quadrant 1, quadrant 2, quadrant 3, quadrant 4. So it's in this direction. So that's counterclockwise. So if it doesn't say anything, by default, you would go counterclockwise. So A is at 2, 2. Okay, A is at 2, 2. B is at 3, 0. And then C is at 0, negative 2. Okay? So what's about to happen is I'm going to rotate this shape 90 degrees, which is an entire quadrant. So every single dot is going to end up in the next quadrant, the next quadrant, the next quadrant. So it's almost as if I'm just doing click and I'm just shifting everything like that, 90 degrees. But we have to do it without turning the paper. So the way that we're going to do that is we're going to shift this into here. So this is going into this quadrant. So now it's going to be here, which is 2, 2, but both of them are negative because this quadrant is negative, negative. So now we know where A prime has ended up. Now, you're not going to notice here, but when you do a rotation, the numbers also rotate, and they adapt to whatever quadrant you're in. I'm shaking a little bit, guys. Sorry about that. So they adapt to whatever quadrant you're in. So C is at 0, 2. So when I shift it, okay, it's going to be 2, 0, and now it's going to be over here at 2, 0, and they're both going to be positive. So 2, 0 is where it's going to end up. So it's ending up right here. This is where C prime ends up. B is 3, 0. So when these rotate, it's going to be 0, 3, which is up here. Now, 0 is supposed to be negative, but there's no such thing as a negative 0. So you're not seeing the actual shifting of the figures. Hopefully in the next one, or the next one after that, you'll see it a little bit better. So this is actually at 0, 3. Okay, so the numbers aren't just swapping. Okay, they're changing signs. Here you don't see the sign change because of the 0 can't be negative. So now you connect them. And there you go. Okay, I have rotated this shape 90 degrees, counterclockwise, so this way. So this shifted that way, this shifted that way, and this shifted that way. Okay, now I'm going to show you what a rotation of 180 degrees is like. Now, every 90, the numbers swap. So this is at 1, 2. This is at negative 1, 2, right? That wasn't, this was at negative 2, 2. Sorry, there we go, negative 2, 2. So this is at negative 1, 2. So it's going to end up 180 degrees. So it's going to shift twice. It's going to do a 90 shift twice. So it's going to go here, here. So it's going to end up in here. Okay? So we know that it's going to be a positive, negative. But also the numbers are going to swap twice. They're going to rotate twice, which means they're going to end up in their exact location. So we know that the answer is going to be 1, negative 2. Ooh, that's horrible too. 1, negative 2. So that's going to be 1, negative 2. That ends up right here. This is where A prime ends up. So B is going to rotate twice, so it's going to end up in here, which is negative, negative. Okay? This one is 2, 2. So it's going to end up, so it's going to rotate the numbers twice, but they're just going to stay in the same location. So it's going to end up to be negative 2, negative 2. So the numbers rotate for every 90-degree rotation. Okay, so for 180, because it's happening twice, they just come back to their original location. So it's actually going to end up where C is. So that's where B prime is. And C is actually going to end up where B prime is. I mean, C prime is going to end up where B is. So this shape is now... Okay, I don't think I can do it with without grabbing the actual paper here. Wow, okay. That's the best I can do. So that's a rotation of 180 degrees. The numbers just end up on the opposite side with opposite signs. So you see how these were two positive? That's going to end up to be both negative. This one was both negative. It's going to end up to be both positive. This was negative 1, positive 2. It ended up to be positive 1, negative 2. So 180-degree rotation literally just changes the signs, and they jump onto the opposite quadrant. Last one is a clockwise rotation of 90 degrees. So let's try this one out. So A, clockwise would mean like this, like a clock. Okay, so A is going to end up over here. A is at negative 3, negative 3, and now it's going to end up in this quadrant, which is a negative positive quadrant. So it's going to end up at negative 3, positive 3, which is up here. Again, bad example. They repeat. Luckily, the B. Yes, the B. So the B is going to end up in here. The B is at negative 2, negative 1. So negative 2, negative 1. Okay? So it's going to end up in this quadrant, negative, positive, and the numbers are going to swap. So it's going to end up at negative 1, positive 2. So it ends up here. Okay? B prime. B prime is at negative 1, positive 2. So the numbers swapped, they rotated, and it adapts to whatever quadrant it ends up in. C is going to end up in this quadrant, so it's going to end up to be negative, negative. So right now, it's positive 4 and negative 1. It's going to end up to be negative, negative, and the numbers are going to rotate. So it's going to be 1, 4. So it's going to end up at negative 1, negative 4. So negative 1, negative 4 is over here. So now this shape has rotated 90 degrees clockwise. All right, and that's it.